Hello students, today we start a new example number 11. So here figures show the detail of the RCC column and calculate the quantity of the following items. So first we calculate the excavation for foundation, second we calculate the filling of foundation trench, third we calculate the PCC work with a ratio of 1:4:8 and its material, and fourth we calculate the RCC work, and fifth we calculate the total quantity of the steel for a column and footing, and sixth we calculate the formwork for a column and footing. So here in a figure, see this figure here, plan and cross section is given and all the dimensions we got in the form of the centimeter. So first we start excavation for a foundation. So here for finding out the excavation always count in the form the meter cube. Clear? So here length, width and height or a depth of the excavation is compulsory we calculated. So we start finding out the height of the excavation. So here h is a summation of the 40 plus 60 plus 30 plus 10, means from the ground level to bottom of the footing, means here from the bottom of the PCC to ground level we excavate the entire area. Here only one column is provided, so write here 1. Then after, for finding out the height of the excavation, so first we sum the 0.40, means convert into meter, means 0.4, plus here 60 means 0.6, 30 means 0.3, plus 10 means 0.1. So here summation of the all the values is a 1.4 meter. Clear? So depth of the excavation or a height of the excavation is a 1.4, and length and width we got from the plan. So plan here length and width, here 100 centimeter is given, means 100 centimeter means 1 meter length and 1 meter width is given. So total quantity for the excavation for a foundation is 1.4 meter cube. Now foundation trenches, filling of the foundation trenches is quantity of the filling is equal to quantity for excavation for foundation, means we are already calculated 1.4 meter cube minus quantity of the concrete work. So after calculating the concrete work, this point is we calculated filling of the foundation trenches. So here quantity of the filling we discussed at the last. Now we calculate the PCC work for a foundation. So here PCC quantity of the PCC work is here dimension is given 100 centimeter by 100 centimeter we got from the plan, and from the section part 10 centimeter thickness is given in a example. So here only single footing is provided, length is 100 centimeter means 1 meter, width is 100 centimeter means 1 meter, and thickness of the PCC work is 10 centimeter means 0.1. So here 0.1 cubic meter we calculated from the plan and section part. Now we calculated fourth point is the RCC of 1:2:4. So here footing with slope and footing without slope. So here footing with slope, we calculated. First we calculated footing without slope. So from the bottom of the foundation to up to this point we calculated first. Clear? But here PCC is already calculated, so from the above the PCC to slope we calculated footing without slope. So here single number is provided, single column is that, so write here 1. Then after length we take from the plan, so 1 meter, width we take up from the plan, so 1 meter, and thickness of the RCC work is a 30 centimeter is already given in a section part, so write here 0.3. So total footing RCC work without slope is a 0.3 meter cube. Now we calculated footing with slope. So here upper part is less and the lower part is higher. So here upper part dimension is given 0.4 by 0.4 and the lower part dimension is 1 meter by 1 meter. So here A1 we take a 1 meter by 1 meter and A2 we take a 0.4 by 0.4. So first we calculate the total quantity of the RCC work for a slope footing. So here volume for the slope portion is h by 3. It's a equation, standard equation, mathematical step. So h by 3 is equal to A1 plus A2 plus A1 A2 raised to 1 raised to 2. So here volume of the sloping portion here h we take from this point to this point we take a h value is 60 centimeter, means 0.6 meter. So write here 0.6. Then after A1 and A2 we are already told that A1 is 1 meter by 1 meter, means bottom portion. So here write here 1 meter by 1 meter. So value of the 1 by 1 meter is 1 meter square here. And upper part A2 part is this part dimension is 40 centimeter by 40 centimeter. So convert into meter, 0.4 by 0.4. So multiplication of the 0.4 by 0.4 we got a 0.16 meter square. Clear? So both the value now put in this equation. Volume of sloping portion, A1 we put here value 1 and A2 we put a value 0.16. A2 we put a value 0.16. Then after A1 and A2, A1 we put a 1 multiplied by 0.16 raised to 1 by 2. So now after calculating h by 3 A1 plus A2 under root of A1 A2, so we got the answer is 0.312. It's the final answer for the volume of the sloping portion. So here volume of the sloping portion we directly write here 0.312 cubic meter. Now we calculate the part of the column below ground level, means this portion below ground level, means from the ground level to up to sloping portion we calculate here. So only single column is provided, so write here 1. Length is 0.4 because as per the plan and as per the cross section part dimension is 0.4 by 0.4, so length is 0.4 and width is 0.4 and height is we take 40 centimeter, means 0.4. So all the dimension write we here 0.4 by 0.4 by 0.4 is 0.064 cubic meter. Now column calculation from the 0.4 by 0.4 meter above ground level. So from the ground level to plinth level we calculated single column is here, so write here single 1. Then after 0.4 by 0.4 column size and height we take, this side we take a 75 centimeter, so right here we take a 0.75 meter. So total quantity is a multiplication of the 0.4 by 0.75 is a 0.12 cubic meter. Then after from the column above plinth level up to this point, clear? So height is given 300 centimeter, means 3 meter. Only single column is there. Above plinth level dimension of the column is 30 centimeter by 30 centimeter, already given in already given in a plan part, 30 centimeter by 30 centimeter, column size is given. So here 30 by 30 centimeter, right here 0.3 by 0.3, and height is 300. See this figure, height is 300 is given, so 3 meter we write. So total quantity is a total quantity is a summation of the 0.064, 0.12, 0.27 is equal to 1.066 meter cube. So it's a total quantity of the RCC work. Now here second portion is pending. So second is the filling of the foundation trenches. So filling of the foundation trenches is a total quantity of the excavation minus concrete work and PCC work in a foundation. So here total quantity of the concrete work, first we calculate total quantity of the foundation excavation is a 1.4. so we here write quantity of the filling is equal to 1.4 minus this portion minus RCC and PCC work below the ground level. So here minus PCC work minus this portion minus sloping portion minus 0.4 by 0.4 portion. So here all the part we calculated in this example. So PCC work is 0.1 meter cube, so minus 0.1 minus RCC work footing without slope is a 0.3 and footing with slope is a 0.312 and part of the column below ground level means up to this portion is up 0.064. so we write here minus 0.3 minus 0.312 minus 0.064, 0.312 minus 0.064. Now we got an answer. .4 minus 0.1 minus 1.4 minus 0.1 minus 0.3 minus 0.312 minus 0.064. So answer is a 0.624. It's a total quantity 0.624. It's a total quantity of the filling work. Now let's we start a steel quantity calculation. So here steel for a column and footing. Here first let's we start with a vertical bar for the column. So here see in this figure 12 diameter 6 numbers of the vertical bar is provided. In this figure 6 main bar is provided, so right here number is a 6. Then after we calculate the length of the bar. Length of the bar is we calculated length of the bar is equal to 3 means 300 centimeter, converting to meter is a 3 plus 0.1 plus here hook is provided at one side at the top side, and for the left portion 0.1 meter is extra provided, means 10 centimeter extra provided at here, and hook is provided on the upper side. So we write here 9 into D, single 9 multiplied by diameter of the bar. Diameter is a 12 mm diameter, converted to meter 0.012. Bracket is closed. So multiplication and summation of the all the values we got answer is 9 multiplied by 0.012 plus 0.1 plus 3. So 3.11 is a total length of the bar. So 3.11 is a total length of the bar. So right here 3.11, and per meter length of the bar, weight of the 12 mm diameter per meter length of the bar is a d square divided by 162. So d square is a 12 mm diameter, so 12 multiplied by 12, 144 divided by 162. So we got answer is a 0.888. So we take a 0.89. So right here 0.89 per meter weight of the bar, 12 mm diameter bar. So total quantity in the form of the kg we got a 16.607 kg is a we got from the multiplication of the 6 multiplied by 3.11 multiplied by 0.89. So it's a vertical bar for the column. Now next we take a dowel bar. So dowel bar we calculated. First we start with the lap length. So lap length is a length we calculated. First we take a lap length. So lap length we take a 24 multiplication of the diameter of the bar. So 24 multiplied diameter of the bar, here dowel bar 16 mm dowel bar, 6 number of the bar is calculated. So here 16 mm, so right here 0.016, it's a diameter of the bar. First we take lap length, then after dowel bar is start from the plinth level to bottom of the foundation. So here we take a summation of the 75 centimeter, 40 centimeter, 60 centimeter, 30 centimeter, and here 20 centimeter at here, and both the side hook is provided here, and this side both the side hook is provided. So let's we also minus the bottom cover minus diameter of the bar. Here 12 mm diameter bar is provided on both the way, horizontal and vertical way, on both the side. So minus this diameter of the bar. So lap length this portion, then after 75 centimeter convert to meter 0.75 plus 0.40 this part, then after 0.60 plus 0.60 plus 0.30 4.6 0.3 plus here 20 centimeter, so 0.2 plus diameter, here one hook is provided, at a single side hook is provided, so 9 multiplied by diameter of the bar. Diameter of the bar, dowel bar is a 16 mm dia, so 0.016, it's a dowel bar hook, minus cover. So here cover is bottom cover we take a 0.05, means 5 centimeter cover is provided, so minus 0.05 minus 2 times diameter of the both the way bars, so 12 mm diameter bar, so 2 multiplied by 0.012. Now we got the total answer is 2.61 meter. So right here 2.61 meter. It's a final dowel bar length. Here total number of the dowel bar is a 6 number of the dowel bar. So in a number right here 6. Then after length we calculated at here 2.61, right here 2.61. Then after per meter length weight of the bar we calculated 16 square divided by 162. So answer is 1.58 kg per meter. 1.58 kg per meter. So multiplication of the 6, 2.61 and 1.58, total 24.74 kg weight of the dowel bar is required. 16 mm dia, 6 number of the bar is required. Now next we start with lateral ties. So here for calculate the lateral ties, number of the first we find out the number of the lateral ties required. Then after also we calculate the length of the lateral ties. So here equation for finding out the length of the lateral ties, L is equal to 2A plus B. So first we calculate the length of the value A. So for finding out the value A, 30 centimeter by 30 centimeter is dimension of the column. So for finding out the value of the A is 0.3, this portion 0.3, minus both the side cover is provided, so minus 2 times cover. So here side cover is 2.5 centimeter side cover is provided, so 0.025 minus 2 times both the side diameter of the stirrup. We minus the both the side diameter of the stirrup, 2 multiplied by 0.006. So here 6 mm diameter stirrup is provided. So we got a answer is 0.238 meter. It's the answer for the A. So the dimension of the column is 0.3 meter by 0.3 meter. So for a value of the B, we also got 0.0238 meter, because dimension of the column is same for both the side. Now 0.238 meter value we put in this equation to 0.238 plus 0.238 plus 0.15. Now we got a final answer. Total length of the one stirrup is 1.10 meter. It's a total length of the lateral ties. Now we find out the total number of the tiles is required. So total number of the ties, we start from the top to bottom up to sloping portion, and up to this portion, bottom of the foundation and above the PCC work. So here number of the ties is equal to, in the bracket 3 means 300 plus 0.75 plus 0.40 plus 0.6 plus 0.3 minus, here cover is provided at the bottom, so minus 0.05 5 centimeter cover is provided, minus 2 times diameter of the bar. So here both the way bar is provided at the bottom, so your diameter is 0.012. Divide by center to center spacing of the stirrups. Here 6 dia link with a 50 cm center to center spacing is provided. So here distance between the two stirrups is 15 cm, is converted into meter, 0.15 meter. So now numbers of the ties required is equal to multiplication and division of the all the values. We got a answer is 33 numbers of the stirrup is required. Thirty-three numbers of is equal to 33 numbers. Clear? Now we write here number is a 33. Length of the stirrup we calculated here 1.10. So write here 1.10, and per meter length weight of the stirrup is the d square divided by 162. So your diameter of the stirrup is 6 mm, so 6 square 36 divided by 162. So 0.22 is per meter length weight of the bar is 0.22. So right here 0.22. So total weight is a multiplication of the 33 multiplied by 1.1 multiplied by 0.22 is a 7.986 kg weight of the steel required for a lateral ties of a column. Then after we calculated the footing of the bar. So for finding out the footing of the bar, this bar, so first we calculate the length of the bar, and then after we calculate the number of the bar. So for finding out the length of the bar, here 100 centimeter by 100 centimeter dimension of the column is given. So 100 means 1 meter by 1 meter. Then after at both the side, this side, left side and right side and left side, both the side cover is provided. So minus 2 times 0.05, it's a cover, plus here both the side hook is provided, this hook and this hook. So plus 2 times 9 into D. Diameter of the bar is a 12 mm dia, is already given, both the way bars 12 mm dia. So write here 12 mm diameter of the bar. Now multiplication and summation of the all the values, we find out the total length of the footing bar is a 1.12 meter length. Clear? So here we write 1.12 meter length. Then after we find out the number of the bar required. Numbers of the bar is equal to, here 1 is 100 by 100 centimeter, means here 1 minus 2 times cover, 2 times cover 0.05 divide by spacing between the two bars. Here 10 centimeter center to center space is provided. So write here 0.10 plus 1. So total quantity of the numbers of the bar we calculated is 10 numbers of the bar required. So for a footing bar, 10 numbers of the bar we take here 10 numbers, but here one point is right here, both the way. For a single way 10 numbers of the bar we calculated 10 numbers, for a both way 20 numbers of the bar, so 10 multiplied by 2, it's a 20. Now per meter length, weight of the bar is a d square divided by 162. So here 12 multiplied by 12 means d square divided by 162. 0.88, answer is a 0.88, right here 0.88. Now multiplication of the 20 multiplied by 1.12 multiplied by 0.88, so answer is a 19.712 kg weight of the total weight of the steel required for a footing bars, 12 mm dia, 10 cm center to center. Now total quantity of the steel for a column is a 69.048 kg. So it's a summation of the all the starting to end, means vertical bar for a column 16.607 plus dowel bar 16 dia 6 number is answer is a 24.743 kg, and lateral ties 7.986 kg. Then after footing bar is a 19.712 kg. So total quantity for the steel required for a column is a 69.048 kg. Now we start a formwork for a column. So here formwork for a column required for above plinth level and below plinth level, means here above plinth level from the this point to up to this. So dimension is here 4 numbers of the wooden plank is required, so dimension right here 4 numbers. Then after width of the plank is here above plinth level 30 cm by 30 cm column size, so right here 3.3, and height of the plank is 300 cm means 3 meter, so right here 3. Then after column below plinth level means this portion up to plinth level to sloping part 75 plus 40, 75 plus 40, so 115 multiplied by 0.4. This type of the 4 wooden plank is required. Dimension is width is 0.4 because below plinth level size of the column is 40 cm by 40 cm, and here we write here 0.4, and height is 115, so we write here 1.15, so total 1.84 square meter. So here summation of the 3.6 plus 1.84, 3.6 plus 1.84, answer we got a 5.44 square meter, 5.44 square meter. Formwork required for the column. Now here this portion and for a sloping part and this part no formwork is required. So because we already cut the or excavate the area as per the standard dimension of the column footing, clear? So no any formwork is required at the sloping part and below the sloping part and in a Pcc work. So here we complete the example of the column, RCC column. Thank you.